We are going to find the length of the graph of the function f of x equals 2/3 x to the 3/2 on the interval from 0 to 3. We're going to do this one by hand because we can. I kind of engineered it this way where we can get a little bit of integral practice in the process of doing this. So step one, let's go ahead and find a derivative because you know you're going to need it. Step one, step zero, I guess, is to really understand what the question is asking. Find the length of the graph, that is arc length. We need this formula. Therefore, we'll take a derivative. Part of this is interpreting the question, and the question asks for the length of a graph. I have no idea what this graph looks like, but I know they're asking for how long it is, which is arc length. So here goes with a noisy marker. F prime of x equals 2/3 times 3/2. Convenient. 2/3 times 3/2 would simply be 1. X to the 1/2 on the interval from 0 to 3. All right, good. Good to know. We got that. So now we're going to plug this into this formula, and it's going to work out quite nicely. So this is the integral from 0 to 3 using the bad marker. Once it goes, I'm just going to chunk it across the room. That's it. I'm just going to throw it. 1 plus x to the 1/2, that's square root, and then we square it, and we get dx. It's about to give out. It's about to do it. The integral. Ready to toss it. Throw it, you're going to hear a crash. Somebody on the outside is like, ow, my head. 1 plus x, just x, there we go. And we're going to take the antiderivative of that, and it's going to involve, dun dun dun, u substitution. Okay, don't panic. All right, here's the deal. We are going to integrate this, and there is an inner function. That inner function is 1 plus x. So let's just go ahead and say that u is 1 plus x. Du is 1 dx, and that's all I really need. So let's move forward. But with u substitution, we have to ask ourselves, are we integrating for fun? Yes. Are we integrating an indefinite integral, like I just need an antiderivative, or are we saying I need a numerical value? This is a definite integral. This one's a definite integral. And the marker that I was just writing with was this one. And if I'm disappointed on the first stroke of the marker, off it goes. Nope, that's the good marker. There we go, equals. You get to live. Not long for you, sir. All right, he's talking to his markers, wow. Integral of the square root of u, and then dx is du, okay. Now, okay, don't be putting 0 and 3 here. Don't, unless you're going to integrate this and turn it back into stuff with x's in it. Let's just keep the u's going. It's going to work. So 0 goes here. We've seen this before. 0 goes here, and I have 1 plus 0, 1. I have 1 plus 3, 4, which is convenient. I'll have to take a square root of these numbers in a minute. So let's keep going with this. 1, 4, this is u to the 1/2 du. I'm ready to take an integral now that I've done a little rewriting on it. And that gives me u to the 3/2 and then 2/3. That looks awfully familiar, doesn't it, actually? We kind of knew this. So it's square root, if I took an antiderivative, it would take me back here. It's similar in the way they're structured. It's not like this problem is working us backwards. It's structured the same. And so it's from 1 to 4. All right, from 1 to 4. That's 3 hours. Just popped in my head. I should have just kept going. So I have 2/3 times 4 to the 3/2 minus 2/3 times 1 to the 3/2. And that's going to give me, well, stuff. What stuff? Let's find out. The square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16. I have 16/3. Okay, good to know. Minus. Square root of 1 is 1. 1 to the 3rd is 1. 1 times 2/3 is 2/3. I have 14/3. That's it. So if I graphed this ridiculousness, which is some little curvy curve, and I only graphed it from 0 to 3 on a scale of inches, for example, then the entire length would be 14/3 or 4 2/3 inches.